Let's go ahead and take a look at two other quick examples about interpreting derivatives. So we had one of these in class talking about the cost of a house and how that changes as the square foot changes of the house. But let's take a look at this one here about a toll road. So in this example, we've got a toll road who charge to ride on that changes depending on the time of the day. So the cost of riding the road is a function C equals f of t, where t is the number of hours after midnight. So 7 a.m. would be t equals 7, 1 p.m. would be t equals 13, and etc. So the first question here asks, what does it mean to say that f of 5 is equal to 2? So let's take a look at that. We say f of 5, we can see the variable here is t equals 5, so t equals 5. T means 5 a.m. The cost to ride the toll is $2. So we're looking at our units here. We're talking about hours of the day. We're talking about dollars. So units will help us answer the next question, which is asking us, what does it mean if dc dt, when t is 8, equals 1? So this is no longer talking about the cost itself, but rather the change in cost with respect to the change in time at t equals 8, meaning at 8 a.m. So let's start by writing the time, which is 8 a.m. dc dt, change in cost, change in time. So we know the units about what we're talking about is going to be dollars per hour. So we're going to be talking about $1 per hour here. So thinking about the change that could be happening at 8 a.m., we know that the toll road's cost for you to ride on it is changing. So thinking about this function, it would seem to make sense that we're talking about at 8 a.m. the cost to ride the road is increasing. We know it's increasing because this is a positive 1. So it's increasing at a rate of $1 per hour. However you want to write that. Okay, we don't know what's going on at 8:01 a.m. We don't know what's going on at 7:59 a.m. But we know from this statement that at exactly 8 a.m., the cost to ride that toll road is going up by $1 an hour. Okay. Next question. Here we've got, suppose that we have this function P of t that tells us the population of North Carolina measured in millions of people, whereas we know t, which is the number of years since the year 2000. So let's explain the meaning of these statements. So question A here is asking us for p prime of 6 equals 0.2. So the derivative of our population function at time 6. So derivative of this function here would be applying the rate of change of this function. So the change in population with respect to time equals 0.2. So this would imply that we have 2 million people per year. If we think about the units here, because we're talking about change in population with respect to time, so people over time. So our little sentence we could write here is in the year 2006, the population of North Carolina was increasing. Again, we know it's increasing because our rate of change is a positive number at a rate of 0.2 million people, or we could say 200,000 people per unit of time, which we're talking about, which is years. All right. Next question, looking at P inverse. This is kind of going back to some of our review that we talked about. The inverse function of P. We think it's the same relationship between population and the year only this function is going to be kind of working in the opposite direction. What we input into this is a population. And what we get out of this function is a year. So this is trying to say it's a non-derivative, it's inverse notation. So it's straight saying to us here, Carolina had a population of 9.3 million people. Okay, and we're not talking about change, we're just talking about the way things work. Okay, now in part C, we're doing both. Notice we're still talking about this inverse relationship. We are talking about the derivative of that inverse relationship. So the units on this, of the actual inverse relationship would have been years, but now we're looking at change in the year based off of, with respect to the population. So because this number 6.5 is talking about so this how many years would it take in order for there to be an increase of 1 million people in the state of North Carolina? So what this is saying here is when the population in North Carolina is 8.1 million people, right? That's what that 8.1 there, P inverse prime of 8.1. We know something is changing. What's changing? The population is changing. It's going to take 6.5 years for there to be another million people. So when the population in Carolina is 8.1 million people, not sure what happened here, the population will take 6.5 years to increase by 1 million people. So I don't know what happened with that first sentence there, so you can just back up the video and take a look at what it was, but I'll say it again. When the state of North Carolina had a population of 8.1 million people, the population will take 6.5 years to increase by another million people. Okay, so the key thing in all of these sentences is to make sure that you're citing specific dates. If you're talking about dates, so units basically, make sure that you're talking about whether, if you're talking about a rate of change, whether it's increasing or decreasing. You can always talk about, you can always tell about that based off of the sign of your numbers, positive rates increasing, negative rates decreasing. And just make sure you always put it in context. You should be able to summarize all this in one nice sentence with a good context as long as you're talking about the units. Use these two examples to help you do your homework problems, and I'll see you in class tomorrow.